Guys, so today I just want to have a quick look. I just want to do a video on ions and how they bond. Okay, so over previous lessons what we've actually looked at is we've said that atoms have a neutral charge. Okay, so atoms have a neutral charge. Now this is because they're neither positive nor negative. Now the reason they're not positive nor negative is because they have the same number of protons and electrons. So this is because they have the same number of protons and electrons. So if we do this as a little recap, a very quick one, if we think of an atom has a central nucleus into which we have protons and neutrons, okay? If this is a hydrogen atom, for example, it has one proton in the nucleus, therefore it will have one shell that has one electron in it. So the number of electrons in the first shell equals the number of protons. The positives cancel out the negatives and this atom is neutral overall. However, if, for example, there are 3 protons in this nucleus, this atom will have to have 2 shells, purely because the first shell only holds 2 electrons and then the second shell would have this third electron. So there are 3 electrons, 3 protons, they cancel each other out, therefore this atom will have a neutral charge. Okay, so that's what we've covered over the previous few lessons, and today I just want to take a good look at ions. Okay, so if we think of an ion, this can be our first keyword, an ion. An ion can be defined as an atom, so an atom that has lost or gained electrons. So the important thing here is that atoms can only lose or gain electrons, not protons or neutrons. Now the reason for this is because if you think about it, an atom has a nucleus, as we've just said, and in that nucleus you have the protons. I like to think of this nucleus as sort of a barrier, kind of like a prison, so the proton cannot get out of the nucleus. However, the electrons that are found in shells can be lost or gained. This is not a barrier, they're free to go wherever they want. So the electron here can be lost or gained. This atom could easily lose this one electron, but what would be far more likely is that it would gain another electron from another atom. Okay? Now, there's 2 types of ion that you need to know about. So, there are 2 types of ion. The first of which is known as a cation. Okay, a cation. So a cation is a positive ion. Okay, so a cation is a positive ion. Whereas an anion is a negative ion. A negative ion. Okay? Now, the important thing here is that we work out, or we learn, how an ion can become positive, how an atom can become a cation, or what makes a negative ion. How can an atom become an anion? Okay, so let's clear the screen. Let's turn it back to black, as Amy Winehouse would say. Let's carry on. So we've said that atoms can only gain or lose electrons. They cannot gain or lose protons. Okay? So let's write this at the top again because it's really important. Atoms only lose or gain electrons. And from previous lessons, we've said that, we'll use this colour, we've said that electrons are negative and protons are positive. So, and protons are positive. So if we've got an atom, let's say for example, off the top of my head, we'll go with sodium. Okay? Sodium has 11 electrons. Okay? Therefore, it's got 11 protons. Now, we can work this out quite quickly because we can say that sodium is in period 3. So, it's in period 3, so it's got its nucleus. The fact that it's in period 3 tells us that it's got 3 shells. 1, 2, 3. And it's found in group 1. So that tells us that it's got 1 electron in its outer shell. So it's in period 3, therefore it has 3 shells. And it's in group 1, so it's got 1 electron in the outer shell. Now that we've done this, we can fill the rest in. So the first shell holds 2, and the next shell holds 8. So 1, 2, 3, 4, 5, 6, 7, and 8. So sodium, this is sodium as we said, Na, period 3, group 1, so Na, has 1 electron in its outer shell. Its outer shell can hold 8 electrons. Okay, so sodium has 1 electron. Sodium has 1 electron in the outer shell. So in its outer shell. But it needs 8 to fill this outer shell. Now, sodium, as an atom, would have 2 ways of completing this. It could either gain 7 electrons from somewhere, it would need to find those 7, or it could lose the 1 electron in its outer shell. Okay? So, it would be far easier for sodium to lose this 1 electron than it would be for it to gain 7. Okay? So if we change our diagram, so it's got 1 electron in its outer shell, therefore it's easier for sodium to lose this 1 electron, okay, rather than find 7 electrons from anywhere to fill its outer shell. It'd be far easier for it to say, right, let's get rid of this 1 electron. Okay, and that's exactly what it does. It'll lose this electron, and then, as a result, its next shell, this shell here, is complete. It has 8. Okay? Now, sodium has lost its 1 electron from its outer shell to complete its outermost shell. This one has 8 in it now. The second shell has 8. However, we have a problem. Originally, sodium had 11 protons in its nucleus and it had 11 electrons. That's why it had a neutral charge. However, it's just lost one of these electrons. So this 11 electrons becomes 10 electrons. If you think about it, it now has one more proton than it does electrons. Protons have a positive charge, electrons have a negative charge. Therefore, this sodium ion would now have a positive charge. It has now become a cation, and we would draw brackets around it and put a positive charge to show that. Okay? Let's look at another example. So we'll switch to a new screen, colour it black again, because it's easier for you to see. Let's take chlorine, for example. Chlorine is a non-metal. It's on the other side of the periodic table. Okay? It's found in period 3, group 7. So if we think of chlorine, you've got your nucleus. Chlorine has 17 electrons, so it has 17 protons in its nucleus. It's in group 3, so it has 3 shells. 1, 2, 3. It's in group 7, so its outer shell has 7 electrons. 1, 2, 3, 4, 5, 6, 7. Okay, and then we can just fill the rest in. The first shell has 2, the next shell has 8. Now the number of electrons, 17, is the same as the number of protons in the nucleus. Okay? However, chlorine has a different problem. Chlorine has 7 electrons in its outer shell. It needs 8 in order to complete that outer shell. So it has, much like sodium did, it has a conundrum. It can either lose these 7 electrons, or it could gain 1. It would be far easier for chlorine to find this 1 electron than it would be for it to give away these 7. So that's exactly what it does. What it will do is it will go away and it will find an extra electron. Okay? But because this electron is negatively charged, it has gained 1 more negative than it has positives. It has 17 protons in the nucleus. It did have 17 electrons, therefore 17 pluses, 17 negatives cancelled each other out. But it's gained this 1 more electron. So overall, this atom would now have a negative charge, a 1 negative charge, and would therefore become an anion, a negative ion. Okay. So, let's quickly recap that with a diagram. Let's quickly go over that one more time for both. So, we've just gone over sodium and chlorine. Okay? So if you think about it, we could draw both. For the quickness of this, I'm only going to draw the outer shells, okay? So if we draw sodium first, we've got its nucleus with 11 protons in, and then it's got its outer shell, which has 1 electron in, okay? Chlorine, on the other hand, has 17 protons in its nucleus, and in its outer shell it has 7 electrons. Okay, so it's got 1, 2, 3, 4, 5, 6, 7. Okay, bear in mind these only show the outer shells. So what would be a really quick way or an easy solution to this problem for sodium and chlorine would be for sodium to give this electron to chlorine, like that. As a result, this atom would lose its electron, this one would gain. And we could draw these atoms again. We could say that chlorine still has its 17 protons, which are stuck in the nucleus. Sodium still has its 11 protons that are stuck in the nucleus. However, they now have full outer shells. So sodium, for example, would have 8 in its outer shell because its outermost shell has lost an electron, so you go to the next one. So this one would have 8. Chlorine, on the other hand, would also have 8 because it's gained 1 from sodium, like so. And if we carry on, this shows that this electron has come from sodium, like so. But because they are now ions, they have different numbers of electrons and protons, we need to draw our brackets around them. So this one has become a negative ion and is therefore an anion with a charge of -1. And sodium has become a cation that now has a positive charge of +1. Okay? These two ions would be attracted to each other. The positive cations would be attracted to the negative anions. This would form what's known as an electrostatic attraction, or more commonly known as an ionic bond. So we can write that down as a key word because that's really important. So we can say, let me just get rid of this so I've got some room. An ionic bond is an electrostatic attraction between an anion and a cation. So sodium has given an electron to chlorine. Chlorine has gained an electron from sodium. Because sodium has one more proton now than it does electron, it becomes a positive cation with a charge of +1. Chlorine gains an electron and becomes a negative anion with a charge of -1. The positives and the negatives are attracted to each other. This is an electrostatic attraction, and this would form what's known as an ionic bond. Now, before I finish the video, let's see if you can work through one yourself. What I will do is I'll set the question up. You can pause the video. You can use a piece of paper or whatever, and you can see if you're getting it right, and then I will go through it with you. So, I want you to imagine that you have got, let me quickly think of some atoms. You have got, we'll say, magnesium, which I haven't got a periodic table to hand, but I want to just make sure I do it right for you. So let me quickly grab a book. No, actually, what we'll do, we'll say lithium, because that's one I can think of off the top of my head. So you've got lithium. It's all gone Pete Tong. You've got lithium, which has 3 protons in its nucleus. Therefore, it has 2 shells with 1 in its outermost shell. So 1, 2, 3, and we've got lithium. And the other one you are going to have is oxygen. Now, oxygen is found in period 3, group 6. So, oxygen has, let me quickly work it out in my head, 2, 10, 16 protons, and therefore it's in period 3, so it has 1, 2, 3 shells. Okay, this is oxygen, and it therefore has 6 electrons in its outer shell. 1, 2, 3, 4, 5, 6. Okay, can fill the rest up. What I would like you to do is I would like you to pause this video, see if you can form the ions made by both oxygen and lithium. Then I want you to see if you could form an ionic bond between them. So pause the video now. When you come back, we'll go through it together. Okay, so hopefully you paused the video. Hopefully you didn't find that too stressful. But let's start by turning these into ions, okay? So lithium has 2 in its first shell. It has 1 in its outer shell. To complete this outer shell, it needs to get 8 altogether. So it is far easier for lithium to lose this 1 electron than it is to gain 7. Okay? Now, this electron, instead of just going off into wherever, into nowhere, this electron will be given to oxygen. So this electron will be given to oxygen, and therefore lithium will then become an ion. It will become a cation because it will become positive. Okay, it still has 3 protons in its nucleus, and its outer shell will now have 2 electrons because it's given 1 away. To show that it's an ion, we need to draw brackets around it. I'll just use white because I've closed the colour chart. It's now become a positive cation because it's lost 1 of these electrons. It has 3 protons, 2 electrons. So that is our lithium ion. Oxygen, on the other hand, is a little bit more difficult. Oxygen has 6 electrons in its outer shell, but it needs 8. Therefore, this has a really big conundrum. It has to think, do I lose 6 or do I gain 2? So it's a lot more easy for oxygen to gain 2 than it is to lose 6. So much like we've done before, they have 16 protons in their nucleus. If we start drawing out our shells, we've got 1, 2, 3. I haven't left myself a lot of room here to do this. You have to just bear with me. It has 2 electrons in its first shell, so 1, 2. It has 8 in its next shell, and originally it had 6 electrons in its outer shell, and we did 1, 2, 3, 1, 2, 3. Now we said up here that lithium donates this electron to oxygen, so it's donated this 1 electron here. But this still means it's only got 7 in its outer shell. So oxygen would need another electron from another lithium ion to form the anion that it becomes. But its charge would be very different. Because it has 16 protons, originally it had 16 electrons, but it has gained 2 electrons this time. So now it would become 2 minus rather than 1 minus. And if you were to draw this as an ionic bond, as an ionic diagram, you would also need to draw another lithium atom here to show where these electrons have come from. So we've got our 2 electrons, and it is an ion, so it has its brackets here. And what this shows, what this diagram now shows, is that The lithiums have donated their electrons to oxygen. These positives are now attracted to this negative in what's called an electrostatic attraction to form an ionic bond. So I hope that's been of some use to you. I hope that everything has made sense. I will be posting some more videos soon, so please keep your eye on the channel for anything that may be of help. Thank you very much. Goodbye.